Okay, I am making this video because I would like to answer a question that I had in an email this weekend. A student asked me for some help with a problem like the ones from section 3.4. We only got a chance to cover ones in 3.4 where the variables are on one side of the equation already in a nice format, but it doesn't always turn out that way. You had some that look a little bit like this. I found this problem. I don't think it's in your book, but it should be able to help you with some homework. So I guess what the problem like this just adds to the problems we did in class is a preliminary step of kind of doing some housekeeping. Because in the ones we did in class, all these variables were on the left side, the numbers were on the other, and because we know how to do algebra, we could do that. So for example, if you take equation 1 here and add a to both sides, add a, the a is no longer on the right hand side, it's now on the left hand side, and this equation becomes a plus b plus 2c equals 10. Doing a similar sort of thing to equation 2, I don't want the negative 2b to be on the right hand side, so I'm going to add 2b to both sides, and that gives me a plus 2b plus c equals 11. And then the last one is already in good format, so we'll just leave it like that. So 2a plus b plus c equals 11. Let me go ahead and label these so we can keep track of everything. Equation 1, equation 2, and equation 3. So, now that we did that preliminary housekeeping, we can go ahead and just solve just like the way we did in class. For example, well, the first step is to take those 3 equations and take 2 different pairs of equations and try to eliminate a variable. So I'm going to choose to eliminate the variable a, which means I need an a and a negative a. So if I take the top equation and multiply it by negative 1, I get a negative a on that top equation. So it becomes negative a minus b minus 2c equals negative 10. In the second equation, I don't want to change, otherwise my a's won't cancel. So the second equation, I'm going to leave a plus 2b plus c equals 11. And I eliminate. A's cancel. I get b minus c equals 1. And it's a new equation called equation 4 with only b and c. Now I can't solve this for b or c yet because there's 2 variables in it. What I need is one more equation with just 2 variables in it. So, for example, if I take equations 1 and 3 now, I can still eliminate the a's, but I would need to take equation 1 and multiply it by negative 2. If I multiply it by negative 2, then I would get negative 2a, which would cancel with the positive 2a in equation 3. So, when I multiply the top equation, equation 1 by negative 2, I get negative 2a. That is a horrible looking 2, I apologize. Let me try that again. Negative 2a minus 2b minus 4c equals negative 20. And now I can cancel again. And the a's cancel. I get negative b minus 3c equals negative 9. And that gives us our second equation. We'll call it equation 5, that only has the variables b and c in it. And now we know from in class, we want to take now equations 4 and 5 to solve for b and c. And a nice thing happens here, because the negative b and positive b are already going to cancel. We don't need to do any work here. So we get negative b minus 3c equals negative 9. And the b's eliminate, giving me negative 4c equals negative 8. Which, when we divide both sides by negative 4, gives us c equals 2. Which is the value of our first variable, variable c. Now, we can take this c equals 2 and plug it into equations 4 or 5 to find b. I'm going to go ahead and plug it into equation 5 here because I have room right underneath it. And when I do that, I end up with negative b minus 3 times 2 equals negative 9. Which gives me negative b minus 6 equals negative 9. Now adding 6 to both sides, I get negative b equals negative 3, which means b equals 3. We can get that b equals 3 by multiplying both sides by negative 1, dividing both sides by negative 1. Either one will give us that answer. So there is the b and c solutions. I still need to figure out what the variable a is, and I can do that by plugging b or c back in any of the original equations. So if I take equation 1 here, a plus b plus 2c equals 10, and plug in b equals 3 and c equals 2, I get the following. I get a plus b, but b is 3, plus 2c, but c is 2, so I end up with 2 times 2, and that's equal to 10. Okay, and now we can do some simplifying on the left here. 2 times 2 is 4, plus 3 is 7. So I have a plus 7 equals 10. And then if I subtract 7 from both sides, I get a equals 3. So now, if I write my answer as an ordered triple, I end up with 3, 3, 2. Okay, so I hope that helped with your homework. If you're still having trouble, feel free to email me or come in, look at our class syllabus, and you can see when I'm going to be available in class next week. I'm sorry, when I'm going to be available outside of class, either during office hours or in the math lab, or you can always go in the math lab. So I will see you next week. Hope you're having a nice weekend. I'll talk to you later.